And in this tutorial, we're going to be talking about removing a node at a certain position within our doubly linked list. All right, so from here, you can see we have our doubly linked list. And all that's different that you might notice is that now we have positions. So this is position 1, 2, 3, and 4. Now from here, there are several test cases that we should consider. So let's go over case 1. Whether or not we're getting a valid position. So let's say I call the remove at method and the position is 0, for example. Well, 0 is less than 1 and 1 is our starting position. So anything less than 1 would be considered an invalid position. In that case, all I'm going to do if it's less than 1 is just return. Another example of an invalid position is, let's say I say remove at position 5. Well, 5 doesn't exist because 4 is our last node. And in order to check that, we could just say if the position is greater than the size, because size keeps track of the amount of nodes that are within our list, then that means that is also an invalid position and all we're going to do is return. So now let's take a look at case 2. What happens if we want to remove the first node? Well, we could check to see if position is equal to 1. If position is equal to 1, we could just call our remove first method. And our remove first method is going to automatically remove this node and update the header to the new first node. Likewise, we could do the same if we were to remove the last node. So how do we know if we want to remove the last node? Well, we could check to see if position is equal to the size. So if the position is equal to the size, that means I want to remove the last node. And we already know how to remove the last node, so I'm just going to call the remove last method. And that's going to make sure that this node gets deleted and that tail gets updated to the new last node. All right, so from here, let's move on to the last case. What happens if I want to remove a position that's greater than 1, but also less than the size? So position 2 or 3, for example. And in this case, I'm going to go with position 3. So I want to remove the third node from our doubly linked list. So how would I go about doing this? Well, the first thing I need to do is create a pointer that points to what header is pointing to. And this is going to be a temporary pointer that we're going to use to iterate throughout our doubly linked list until we reach to position 3. All right, so for our loop, we're going to start at position 1. We're going to be using a for loop. And all the loop is going to be responsible for is to keep advancing our current pointer until we reach position 3. So let's see what happens when we enter the loop. So the loop executes, current is going to be advanced to current arrow next. That would get us here. Then execute the loop again. Current is going to be advanced to current arrow next. And that would get us to here. So now that we reach this point, it's going to kick us out of the loop because we already reached position 3. So now let's think of this logically. I want 2 to point to 4, and I want 4 to point to 2. So who has all those pointers? Well, position 3 has that, right? Position 3 has a pointer to 4, and position 3 also has a pointer to 2. So now what I want to do, so let's break this down. I want 2 to point to 4. So let's do that part first. So how would I get to 2? Well, in order to get to 2, I need to say current arrow PWEV, right? And that would give me this pointer here, which is pointing to 2. So that would get me here. Now from here, I could say arrow next to access the next pointer for 2. So just to recap, I could say current arrow PWEV, arrow next would give me here. Now, what do I want next to point to? I want next to point to 4. So who has a pointer to 4? Current arrow next points to 4. So now I could just say current arrow PWEV, arrow next points to current arrow next. Now that would give me something like this. So now I have to find a way to make 4 point to 2. So who has access to the previous pointer of 4? Well, from here, I could say current arrow next, which will get me here. Then I could say arrow puev, which will get me this pointer. And I want to make this pointer point to 2. Now, who has a pointer to 2? Well, current arrow puev will get me to 2. So I could just say current arrow next, arrow puev is going to point to current arrow puev. So now I should get something like this. So you can see that our linked list is maintained. All the nodes have a pointer to the next node and to the previous node. Now what we need to do is delete whatever current is pointing to. And the last step from here, since we successfully deleted the node, decrement the size. Alright, so from here, let's actually take a look at how we can implement this with code. Alright, so we have our remove at method here. It's not returning anything, so it's void. And we're passing in the position of the node that we want to delete as a parameter. So let's take a look at case 1. Check if the position is a valid position. So for example, we start at position 1. So any position that is less than 1 is not a valid position. Likewise, if the position being passed in is greater than the size. And the reason for that being is that if you try to delete at a position that's greater than size, that position simply doesn't exist because that's greater than the number of nodes within our list. Now from here, we're just going to return. And that's because the position provided cannot be deleted because it doesn't exist. Alright, so now let's move on to case 2. Check if the position is the first node. So how would we go about doing this? Well, it's pretty simple. We could check if the position being passed in is equal to 1. That effectively means that I want to remove the first node within our list. So I'm just going to come down here, just going to say else if the position is equal to 1, and we're just going to call the remove first method. And this is going to get rid of the first node within our linked list. Likewise, if we move on to case 3, check if the position is the last node. So how do I know whether or not the position being passed in is the last node or not? Well, if I come down here and say else if the position is equal to size, because size is always the number of nodes within our list. So it's always going to be equal to the last node. Now from here, what I can do is call remove last method. And this, of course, is going to remove the last node within our list. Alright, so now let's move on to case 4. Check if the position is between first and the last node. Now, I can use an else statement because we have exhausted all other possibilities. But just to double check, I'm just going to say else if the header does not equal to null. And that's just to make sure that the list is not empty. Alright, so the first step is to create a temporary pointer that's going to point to what header is pointing to. And that's because we have to traverse the list until we hit the position of the node that we want to delete. Next, we're going to create a loop. So I'm just going to create a for loop. I'm going to say int I is going to be initialized to 1. And we're going to keep going until I is less than position. And from here, all we're going to do is keep advancing to the next node until this condition is no longer true. Alright, so now that we reach the node that we want to delete, we need to take advantage that we have a pointer to that node, and that node has a pointer to the next node and to the previous node. So we need to link those two nodes together before we actually delete what current is pointing to. Alright, so from here, current is going to be pointing to the node that we want to delete. But we just can't outright delete it. And that's because it would destroy our linked list. So what we need to do before we delete it is save the previous node from current. So the node that comes before current has to point to the node that comes after current. So how would I go about doing this? Okay, so let's break this down. I need to get to the previous node before current. So how would I go about doing that? Current arrow prev will get me to the previous node before current. Now I need this node to point to the node after current. So now I need to access this node's next pointer. And this pointer is going to point to the node after current. So how do I get the node after current? Well, I just say current arrow next. That will give me the node after current. Now I need to do the same thing, but kind of in reverse. Now I need the node after current to point to the node before current. So first thing I need to do is get the node after current. And we already saw that here. So I'm just going to come down here, current arrow next, gives me the node after current. Now I need to access the previous pointer and make this point to the node that's before the current node. So how do I do that? Well, I could just come down here and say current arrow prev. So that would effectively save my linked list. Now I could delete current. So I'm just going to do that right now. Delete current. And since we successfully deleted the node from the list, decrement the size. So I'm just going to save this. Let's go down to our main method. And I'm just going to change this to remove at. And I want to remove at position 2. So 2 should not be in our list once we print it out. So now I'm just going to save this. Let's bring up the console. I'm going to go to my program. And let's actually run this. And you can see we get the output of 1 and 3. That's because we appended 1, 2, 3, and we wanted to remove at position 2. So 2 was at position 2 and it was successfully deleted. So that pretty much wraps it up for our remove at method for our doubly linked list.